everyone, welcome to my video series on statistical significance testing. So in this video, we are going to talk about a very interesting test which is known as ANOVA test. But what I want you guys to do is before you go through ANOVA test, it is good to go through the t-test video, the link of which I will actually put in the description, because ANOVA test is basically a more generalized version of the t-test. But even if you don't know about t-test, don't worry. In this video, it's not a requirement basically. It's not a requirement to understand t-test to understand this video. That's what I'm saying. Okay, so let's dive in. So first of all, ANOVA means analysis of variance. Although this name is not that clear, but hopefully throughout this video, the name will be clearer. And we are going to talk about one-way ANOVA test in this video, which is what typically people describe as ANOVA test. In the next video, probably I'm going to talk about the two-way ANOVA test, and I will leave a link in the description as well. So let's start with an example. So suppose these are height of men. So these red ones are height of Bangladeshi men. These green ones are heights of Pakistani men. And these blue ones are height of Indian men, right? Okay. Now, the question that we may ask is, are these heights significantly different or not, right? So before I talk about that, let me also get away some notations, because these notations will be used throughout the video. So here K and N, K is the number of groups. So here K is equal to 3 and N is the total number of samples. So total, I think there are 30 samples right here. So N equal to 30 right here. So as I said before, we are trying to compare the heights of these three different groups. So this is going to be the null hypothesis, where we say that all of their mean heights are actually the same. And then the alternate hypothesis is actually very interesting. This is very, very important to understand that at least one country has a different male height. This is very, very important. So suppose Bangladesh and Pakistani guys, maybe they have the same height, but Indian guys have a different height. Still we are going to reject the null hypothesis. So even if only one of the three groups are actually different in height, then it is okay. It is okay to reject the null hypothesis and for the significance to be statistically significant. Now, understand that I am showing you an example with three groups, but there can be more than three groups as well. There can be 4, 5, 6, 7, 8, however many groups you can imagine. Now, you can actually see that when we compare two groups, right? If there were only two groups, then we could have just used the two sample independent t-test, right? Which I actually described in my t-test video. And as I said before, I will leave a link in the description of that video. But when you have more than two groups, then t-test becomes a bit cumbersome. Let me tell you why. So this is the problem with two sample t-test. The first one is we need to do pairwise comparison between all possible group pairs. So here, red, green, green, blue, and blue red. We need to compare these three pairs. Now imagine that there are 10 groups, so we are going to have to compare 10 C2, 10 choose 2 number of pairs basically. So the thing is, what is the problem with comparing so many pairwise groupings? The problem is there is a thing called false positive. So what we may do is we may mistakenly reject one or two null hypotheses, because when we do so many tests, obviously there will be some tests where we make some mistake. And so we are going to basically reject the null hypothesis mistakenly, right? So we don't want to do that. So understand that, later on in the video series, I'm going to talk about error correction as well. Now understand that it is very, very important to minimize the number of tests we actually perform to test something, basically, in order to minimize the false positives. So the next question is, why does this problem fall in the one-way ANOVA category? Very important question. Understand that this attribute height is affected by only one factor here. What is that factor? That factor is country. So which country that person belongs to. Now suppose we also have the gender, right? We also categorize by gender. In that case, there would be two attributes influencing the height. And in that case, we are going to talk about two-way ANOVA, which we are not going to talk about in this video, but in a later video. So let's first actually take a step back and let's actually see each of the steps of the ANOVA test. Step 1, get mean for each group. So you need to get the mean for each of the three groups. Step 2 is to get the overall mean. So if you just sum all these heights up and divide by 30, you are going to get a mean, and that is this mean, suppose. Step 3 is going to be get sum of overall mean to group mean distances. right? So you have these three distances, you have these three means, and you can take the distance from the overall mean, and you can sum these three things up. So that is going to be the sum of overall mean to group mean distances. So just sum these distances up. Step 4 is going to be crucial. It is going to give you the variance between groups. So how does it happen? You need to divide this sum by k minus 1. Now, you may ask why does actually dividing by k minus 1 give us variance between groups? It is quite simple because here you are actually looking at deviation, right? A distance means deviation. So sum of deviation divided by degrees of freedom is equal to variance. I think you know that. That is like statistics 101. So that is why we are going to get the variance. And why it is between groups? Because here we are calculating variance with respect to the overall mean to all the different groups. That is why it is between groups. Now understand that if this quantity is large, that means it is highly likely that the null hypothesis will be rejected. That means these groups, or at least one of these groups, are actually very different in terms of means. Because if one of these groups is very different, for example, this group is very different from the mean, then this distance will be very, very big. So bigger distance means bigger probability of actually rejecting the null hypothesis. So just bear this in mind. So next step is step 5. Step 5 is to get sum of intra-group mean to sample distances. So you can see that these are the group means, and we can take the distance of each group mean to all the corresponding points. And we can sum all these black lines up. So if we sum all these black lines up, we are going to get the step 5 distance measure. Very, very important here to understand is in the simple ANOVA test, we assume homogeneous population level variance. That means we assume that all three groups have similar variance. They don't have to be exact, but they have to be very similar in terms of variance. What if they are not similar in terms of variance? I'm going to show you a method that works on that later on in the video. So don't worry about that. But for now, just understand that the variances have to be very similar. Next step is step 6, where we divide step 5 sum, divide this sum by n minus k. So n is the total number of samples and k is the number of means, right? So this is 3 in this case. So why do we divide by this? As I said before, for the variance, we need to divide by degrees of freedom, and this is the degrees of freedom when it comes to the number of samples, right? And so this is going to be called variance within groups. Variance within groups. So understand that if the variance within the groups, is very, very small, that means it is very, very tight, then it will be much easier. It will be much easier to separate out the means. On the contrary, if all the groups are very spread out, then we would not really know whether the means of the different groups are actually very different or not, right? So variance within groups has a negative effect on the p-value. So when we have a high variance within groups, then we are going to have, it will be harder for us to reject the null hypothesis. That means it will be harder for us to say that the means of the different groups are different and they will all look very similar when we have a large variance. That is why in step 7, we actually calculate this one single value called f, which is called the f statistic, which is basically nothing but variance between groups, which we saw in the previous slide, divided by variance within groups, which is right here. So when we have a large variance between groups, right, then f value will be bigger. And obviously when we have a small variance within groups, that means these are very tight, then we also will have a larger f value. So when we have a large f value, we are going to have a higher tendency of rejecting the null hypothesis. Now, this is very, very important to understand that this f value actually comes from the f distribution, which we talked about in detail in our probability distribution video series, and I'm going to leave a link of that in the description as well. Okay, so it is important for you to understand the f distribution, because f distribution is also a ratio of variance of two groups. That is why we call it f statistic, right? So in the f distribution, the f variable is nothing but a ratio of two variances of two different groups. So in the first group, we have degrees of freedom of d1. In the second group, we have degrees of freedom of d2, and it is k minus 1 in d1 and n minus k in d2, right? As we mentioned here before. Now, the step 8 is to get the p-value. In order to get the p-value, we need to understand how the f distribution looks like. So for different d1 and d2, you can see that the F distribution can vary quite a lot. So let's assume that we have D1 equal to 5 and D2 equal to 100. In that case, the F distribution will look like the green curve. And you can see that if for example, suppose our F value is 1.8, in that case, this entire area, which is marked as red, is going to indicate our p-value, which is 0.25 right here. So understand that if our f value would be bigger, that means variance between groups is larger and variance within groups is smaller. That means f value is bigger. So suppose the f value is 4, right? In that case, only this portion right here will fall under the area, and probably it will have a very low p-value, which is going to be something like 0.01 or something, and then we could reject the null hypothesis. So for this case, what's happening here is, since ANOVA is always a right tail test and p-value is greater than 0.05, H0 cannot be rejected, and so we can conclude that the three countrymen heights are overall similar. Now, one thing I want to mention here and want to clarify here is, what do I mean by always being right tail test? So understand that the f value could be very, very small. It could be maybe 0.05 or something. In that case, some people may think that, okay, that is also an extreme case, right? Because it is also in the tails. But no, here we only care about the maximization of difference. That means we only care about the right skewness. So f value being very, very small doesn't matter. It will not be statistically significant. That is what I wanted to get through. Okay, so now let's see some cases. Let's see case number 1. Let's see these three groups. So what do you think? Are they going to be statistically significant? That means, are they different? And the answer is obviously no, because they are not different. Their means look very similar. So are they different? Obviously no, because their means are also very similar. Now the question is, are they different? Yes, they are different. These two groups are similar, but this group is different. So it is going to be statistically significant. That means they are different. Next thing is this. So here I know that by eyeballing, you actually think that, okay, they are different. But the thing is, there is also a lot of within group variance. That is why most likely this will not be statistically significant. So it is just to give you an idea about how ANOVA test is working. Now, the next question is, as I said before, that the group variances need to be homogeneous for the vanilla ANOVA test to work. Now, what if the variance is very different between the groups? So what if these groups look like this? So variance is actually homogeneous between these two groups, but in this group, variance is very, very small. So what happens then? So first of all, the normal ANOVA test will not work. So there is a special category of ANOVA test called Welch ANOVA test. So here you are going to assign higher weights to groups with lower variance, that means groups that are tied, and with higher sample number. So if you have a higher sample number in some group, there will be more weight to it. How will those weights affect the analysis? The weights will influence the overall mean calculation and the variance between groups calculation. That means the numerator of the F statistic. And finally, the within group variance, which is basically the denominator of the F statistic formula, that will be replaced by some uncertainty measure of these different groups. So I am not going to talk about the details of Welch ANOVA here in this video, but I just wanted to give you an idea that there is such a test existing, which you can use when you have different variances in the different groups. So if you like the video, feel free to subscribe and share. And there's a link in the description for donation. If you feel like supporting our channel, you can donate to that link. Thank you very much.